Professor, my name is Om, and this is my video submission for assignment 3. In this video, I'll walk you through the key parts of the assignment, including the code implementation, results, and an answer to the provided questions. Okay, so part A, image called convolution. So we'll first import this necessary packages and libraries, and then we'll get the image, we'll visualize it, get the bytes, and then we'll see the whole image. Okay, so convolution is a mathematical operation used in an image processing to extract features such as edges, lines, and textures from an image. So in part A, we have applied different kernels to a car image to detect specific patterns like 45 degree lines, and then 135 degree lines and the edges. Alright, so let me just run all the coding part so we'll able to see what exactly it's happening. So convolution with 2D, so create an output and then padding, and then we'll plot it. So this is how it will look. So this is the standard convolution. Alright, function with 2D, then there is the line detection. So this is the things which I were talking about. We'll focus on the vertical lines of 45 degrees. Alright, so when I run it, it showed these things. So now we'll run the kernels of an above image detecting 45 degree lines using convolution, and we have applied it to the car image. So as you can see, when I run it, it will show me the 45 degree line detection. Now we will do the 135 degree lines. Alright, when I run it, it will show again. So after that, the convolution output clearly shows that how different kernels emphasize specific nature of the image. Got it? Let me also do this thing as well. So as you can see, the edges and these two images are so totally different. This one as well with kernel 2 and kernel 3. Let's move to our part B, which is neutral network model. Okay, so first is our database preparation. For part B, I used Cipher 10 dataset, which consists of 60,000 images across 10 classes. The dataset was pre-processed by normalizing pixel values to range of 0 to 1 and one hot encoded label. Alright, so let me import the necessary package first. Then we load the dataset, and then this is one hot coded target values. After that, we are building the neutral network model. So once this model is been created, I've showed the model summary over here. As you can see, everything is there. So the original model has one convolution layer followed by a max pooling and flattening. Okay, and two dense layer. It achieved a training accuracy of 94 but showed a sign of overfitting as a validation accuracy plateaued around 63 to 66% after epoch 10. So these things I was talking about, this model. Okay, I've already run it. I don't want to run it again because it takes a lot of time to execute. And so as you can see, this is the accuracy curves, accuracy graph of how this model is been working. So to address overfitting, I've added dropout layer after each convolution layer, and before the output dense layer. Dropout randomly deactivates neurons during training and to prevent reliance on specific neurons and improve generalization. So these are the accuracy curves. So here is the plot showing training and validation accuracy for the model with dropout layers. display graph. As you can see, this is the displayed graph. Dropout reduce overfitting slightly by narrowing the gap between the training and validation accuracy curves. Okay, now we move on to the our questions 3 to 10. So question 3, did the network present the signs of overfitting? If so, in which? So yes, the original model shows signs of overfitting starting around epoch 10 to 15, where validation accuracy plated while training accuracy continually increases. Okay, so in about the question 4, the write down the how many layers. So the original model had 5 layers: one convolution layer for feature extraction, one max pooling for dimensionality reduction, one flattened layer for reshaping the data into a vector format, and two dense layer for learning patterns and classification. Okay, let's move on to the brief question 5th. Briefly explain what is the purpose of those each layers. Okay, so these are my answers. Let me summarize in one statement. Like, each layer serves a specific purpose. Convolution layers extract features, pooling layers reduce dimensions, flattened layers prepare data for dense layers, and dense layers learn patterns and classify outputs. These all are the specification and the key roles which the explanation of the purpose of each layers. Okay, so to summarize the add one more convolution. So adding an extra uh, wait, question 6, yeah, add one or more convolution layers to your model and run it again. So by adding an extra convolution layer, increasing training accuracy but did not significant improve validation accuracy due to persistence overfitting. As you can see, uh, did added the extra convolution layers, and then when I compiled it, this is the graph which I've got. Okay, so when I compared the difference, these are the key difference which I've got. Training accuracy, the bigger model achieved higher than accuracy due to its increased capacity to learn from training data. The graph is somewhere different, and the bigger model showed slightly stronger signs of overfitting as the evidenced by the weighting gap between training and validation. Alright, so while adding extra convolution improved the training accuracy, it did not lead to significant improvement, as I've said earlier. Okay, so let's move to the question 8. uh, so in here we added a dropout layer which reduces overfitting by forcing neurons to learn redundant representation instead of relying on a specific neurons. As you can see, the graph totally changed. So the dropout layer helped the reduce overfitting by forcing neurons to learn the redundant representation instead of relying on the specific neurons. So explain in your own how to the purpose of the dropout layer and how it works. I already explained briefly in this. Alright. So to summarize, the assignment helped me to understand convolution operation in image processing and how neural networks can be optimized using technology used like adding layers and dropout regularization. Okay, so thank you for watching my submission, and thank you so much, sir. Thank you.